during the 3rd century BC in Egypt. There were no satellite imaging technologies such as Google Earth, where you could log into your computer and with the click of a mouse, look at the entire geography of the world. There were no means of transportation like a plane, where you could look out the window and see the vast ocean or beautiful mountain ranges. To people living in Egypt at the time, the world seemed like a very immense place. And the size of the earth was actually first calculated in a simple and ingenious way by a mathematician and geographer by the name of Aristophanes. At the time, he was appointed as the chief librarian in a city in Egypt called Alexandria. And while working there, he read something peculiar in a book made of papyrus. Carl Sagan, a famous astronomer, in the text The Measure of Aristophanes, said that what he read went a little bit something like this. At noon on June 21st, in the southern frontier outpost in Cyrene, no vertical sticks cast shadows. And this is, of course, because on June 21st, it is summer solstice. And in an article written by M. Pidworny in 2006 about the Earth-Sun geometry, it states that for places like us along the Tropic of Cancer, the Earth is rotated at a degree 23.5, or rotated at 23.5 degrees, and we are exposed to more sunlight during this day. And coincidentally, in that city in Cyrene, the sun is perpendicular to the Earth, so there was no shadow cast when he erected a vertical stick. So curious, Aristophanes decided he would erect a stick in Alexandria, which is a city 600 or 500 miles away from Cyrene, on the 21st, and see if it cast a shadow. And it did. It cast a prominent shadow. And this is what led to one of the most important mathematical discoveries in history. Now, see, the popular belief at the time was that the world was flat. And if the world was flat, then the angle at which the sun's rays hit both sticks should be the same, right? That means the shadows cast should be the same at both places. But in Syene, there was no shadow, and in Alexandria, there was a shadow. So, contrary to popular belief, Aristophanes stated that the Earth must be round, and he set out to calculate its circumference. So before I explain to you how he did this, I'd like to explain a simple geometric property, and that is, if you have two parallel lines, and one line intersecting them at an angle, you create complementary angles. So for example, the two red angles inside the red parallel lines would be considered alternate interior angles, and they're congruent, which means that they share the same angle. And similarly, the two red angles outside the parallel lines are considered to be alternate exterior angles, and they are also congruent, and they share the same angle. So if you were to look at this diagram of the city, or that is the world, and that's the town Syene in Alexandria, you could say that the line of the stick perpendicular to the ground in Syene, extended to the center of the earth, forms a parallel line with the shadow cast in Alexandria by the vertical stick. And you could therefore say that the transversal line, or the line that intersects those two at an angle, would be the stick perpendicular to the ground in Alexandria, extended to the center of the earth. So as you can see, there's a complementary, or an exterior, or an alternate interior angle created between the shadow and the degree between Alexandria and Syene. And he calculated this degree to be 7 degrees. And he also calculated the distance between Syene and Alexandria to be 250,000 stades, which in an article written by James Evan in 2015 about Aristophanes explains it's a Greek unit of measurement, which is approximately 157.7 meters. And as I said before, this is roughly 500 miles or 800 kilometers. So by setting up a simple proportion, he said that the angle of the shadow over 360 degrees is equal to the distance between Syene and Alexandria over the circumference of the earth. So simply put, if the angle of the shadow is approximately 7 degrees, this is 1/50th of 360 degrees. So the distance between Syene and Alexandria must be 1/50th of the circumference of the earth. So by doing some simple cross multiplication and algebra, Thomas Duska, in an article written in 2012 about Aristophanes, said that he calculated the Earth's circumference to be 40,000 kilometers. And this is extremely impressive because currently, with satellite imaging technology, NASA has calculated the circumference of the Earth to be 40,075 kilometers. So yes, that means that with only a couple sticks, some curiosity, hard work, and math skills, Aristophanes was able to calculate in the 3rd century BC within 75 kilometers of the actual circumference of the Earth. And while at one point we may have thought that the world was an immense place, with math and science, we've been able to determine that we are not merely but a grain of sand among a seemingly infinite universe.